Hello M2, this is Teacher Win and I want to say Happy New Year 2022 to all of you M2. So for this video, we are going to learn about simple machines. So let's have first a short review about our lesson last week. So it was about power and work. So if we talk about power, so we are talking about the amount of work done in a given time. So in power, we use the unit watt or watts, W-A-T-T-S, to show or express how fast a machine or a person can finish a task or activity in a given time. Next, we have the word work. So work is defined as force times or multiply by distance. So I hope you watched the video about work because work in science is different in work in ordinary ways. So in work, so the unit used is about joules. So your joules will show you how much work is done or applied to an object, considering its force multiplied by its distance. And finally, we've learned already about force. So force is simply a push or a pull, and its unit is expressed in Newton. So for more lessons about your simple machine, so you can read pages 61 to 62 and go directly to page 64. So these simple machines are not new to you, M2. So these were the lessons when you were in P5 or in P6. So you have here the 6 simple machines. So if you talk about the word simple, meaning easy, right? And machine are like your gadgets or machines. It can be any object that can make our lives easier. So therefore, these simple machines are used so that our work will be a bit faster without using difficult machines. So what are these 6 simple machines? So we have here your inclined plane, screw, screw, wedge, wedge, lever, lever, pulley, pulley, wheel and axle, wheel and axle. So again, so your 6 simple machines are used to make our lives easier by making use of your effort, or shall we say the force that you use, so it can minimize or lessen the force that you're going to use. Like for example, in moving the object, so you're going to use less force, right? So if the objects are very heavy, so you have here your simple machines that will help you move that object. So despite or even if the size is big or even if it is heavy, so with your simple machines, you only need less amount of effort or less amount of force to be used to move those objects. So let's begin first with your lever. Lever. So what is a lever? So it is a beam or a straight or rigid object that can be used as your seesaw. So if you still watch or remember the lesson about moments of force, so those examples that we've used, so those were examples of your lever. So in this topic, so lever, so it has different parts. So let's identify and read those parts. So in your lever, so we have here your fulcrum, which is the center of your lever. Not necessarily center, it is where that you place this beam or rigid object wherein your fulcrum will act as your turning point or your pivot point. And then we also have your load. So your load, so or resistance, so this can be usually a heavy object, and then or not necessarily heavy object, this is the object that you want to move around, that is your load. And then your effort, so your effort, basically this is you, the force that you are going to apply in order to move this load. So we have here the word input. So again, so input and effort, they go together. So if you apply force, so that is an in meaning to enter, to apply force. And then we also have your load, which is the object that should be moved. So that will be our output, meaning the exit, okay, to where our effort is being applied to. So we also have here, so the side where you put your effort is your effort arm, and then your load arm, that is the arm, or this is the part where you put the load. So in your lever, so it has three types, so we will be going on in each type. So basically, so how does a lever work? So, or shall we say, how does your lever help us? So once again, so if an object is very heavy, so it means it has a bigger force. So if you want to move that object without applying the same force, so you have to use a lever. So I hope you move, or I hope you remember about your moments of force, wherein if the object is bigger, right? If the object is heavier, it should be moved closer towards the fulcrum, right? So that there will be less amount of force to be applied. However, so if the object is lighter, so you can use or you apply force near the fulcrum. So again, so with your lever, so despite of the bigger force, so you only need small force to move this object up. Okay, in your first class lever, so we have here the effort, the fulcrum, and the resistance or your load. So I want you to remember that in first class lever, the center is your fulcrum. So you can just simply write your EFR, EFR, so EFR. Or you can just write REF. However, the most important is this fulcrum is the center of the two in your first class lever. So in here, so effort or that's the force that you apply moves further than the resistance. So remember, if the object is heavier, it should be closer to the fulcrum so that the the force that you will apply will be lesser. However, you will be moving away from the fulcrum. So in your first class lever, so it multiplies your effort. So meaning your force that you applied will become stronger, thus changing the direction of your load. So like for example, if I use 10 Newton in my effort, so using your first class lever, so that 10 Newton can become like 15 Newtons, or it can be like become 20 Newtons in order to move my resistance or load. So what are some examples of your first class levers? So we have here your crowbars, your scissors, your pliers, your tin snips, and your scissors. So in here, so we have here like pictures of your first class levers. So let's try to identify the different parts. So we have here your effort, right? Your effort, your fulcrum, and then your resistance or your load. So we're in your fulcrum is the center. So in here, so this will be like your load or resistance. So this is your effort, and this one is your fulcrum. Next, we have here your picture. So if you can see here in the picture, so it's up to you how do you interpret this one. So in here, this will be your fulcrum. And then this one, this will be, can be your load or resistance. And then this one will be your effort because I want to move this boy. And fortunately, this boy is successful in moving this boy. So next we have here your pliers. So this will be your fulcrum. And this handle here, this will be my effort. So this is where I'm going to apply my force. And then here, this is where I'm going to apply the or put the object. So your object here is your load or your resistance. Okay, for the second class lever, so please take note that the center now is your load or resistance. So it is like your FRE, wherein your resistance or your load is now the center. So in second class lever, so your effort moves further than the resistance. So please take note that this is your your effort, right? So you're going to apply further than the resistance. So also, just like your first class lever, so it multiplies the effort, meaning, so if I use 10 newtons, so if I use second class lever, so my 10 newtons can become or as strong as 15 newtons or 20 newtons. However, this does not change the direction of your load or your object. So we have here some examples of your second class levers. So that includes your nut crackers, your wheelbarrows, your doors, and your bottle openers. So let's try to look at this picture. So this is a picture of your nut cracker. So if we identify the parts, so this will be your fulcrum. So just a reminder, in your second class lever, so the center is your resistance. So we have here your effort, the center is your resistance, and then we also have here your fulcrum. So this will be your fulcrum, so therefore this part is my resistance or my load. And then this handle here, this will be my effort. Next, we have here your wheelbarrow. So this part here is my fulcrum. This is the object, so this will be my resistance or my load. This part here is where I'm going to put on my hands so I can apply the force. So this one is my effort area here. In your third class lever, so we still have your FER. However, the center is now your effort. So if we have fulcrum here, so the effort is your center, and then or center or in between your fulcrum and then your resistance or load. However, in your third class lever, so it does not multiply the force. Okay? Also, just like your second lever, so your resistance move further than the effort. So the focus of your third class lever is that it multiplies the distance. Okay? So it will allow the movement, okay, of your load as your effort is increasing or being applied. So what are examples of your third class levers? So we have here your tweezers, your arm, and then your shovels. So in the picture, so we have here a picture of your arm. So remember that in your third class lever, the center is your effort. So it is in between your fulcrum and then your resistance. So in your arm, so your hand here with the object, that will be your resistance or your load. And then in here, this part here will be my effort here, and then this part here will be my fulcrum. In your shovel, so this part here will be my load or resistance, and then here this is where you're going to place your hands, right? So one hand is here, then the other hand is here. So this part of your hand is my effort, and then this part here is my fulcrum. So to learn more about how does your lever help you, so please scan this QR code and you will be guided on an experiment about lever. Next is we have your inclined plane. So inclined planes, or shall we say slope, okay, sometimes I call it like your slope or just simply as your stairs. Okay, so it is a flat surface that is higher on one end. So that means if this is your ground and I have here like maybe a higher floor. So if I put an object higher than the ground. So that means it's like this. So I put an object that is higher, okay, higher than the ground. So this object here is my inclined plane because the other side is higher than the other side. So in inclined plane, so it makes the work of moving things very easier. So you can just easily push the object to the higher floor, or you can just roll the object to the lower floor. So speaking of your inclined plane, so we have here a short formula on how does your inclined plane help you. So we have here your work input, that is your in. So remember that your work is equals to force times distance. So in your work input, that is the amount of work done on a machine. So that means this will be your effort. Okay, that this is your effort side. And then your work output is the load of work done by a machine. So this will be the load side. So we're in both formulas, it requires force and then your distance at the same time. So looking at our example, so we have here your D out, so this is the distance, okay, out, and then the distance input, and then we have here your force input, and then we also have here your force output. So 10 Newton here, this is the force of gravity, and then 3 meters is the height of this inclined plane. And then you want to move an object from this point to this point, and the distance is 15 meters. So the question is, how much force do I need to move the object from this point going up? So please remember that in your work input and work output should be the same, right? So we're in your work output, so we have here your output force and then your distance output multiplied by your input force and then your distance input. So we're in. So our force output here, that will be 10 newtons, right? Because this is your force of gravity. And then your distance out here, so it is 3 meters because we're talking about the height of the object. And then your force input here, in the first place, we don't know yet. So we have here your distance input, which is your 15 meters. So to put it simply, so if you have here your force output and your distance output is equals to force input and your distance input. So that will be 10, right? Multiply by 3 and you will get 30. That will be x and then multiply by 15. So that will be 15x. So if we divide it by 15, both sides, so that will be 15 and 15. So 30 divided 15, you will get 2. So this will be our missing force input. So please remember this is force, so you're going to use the unit Newton. So 2 here is 2 newtons. So to learn more about inclined plane or how does an inclined plane help us, so please scan this QR code and watch the experiment about inclined plane. So for your homework M2, please answer page 68 number 2 and page 69 activity number 3. So that's all for the lesson for this video. So I hope you learn about lever and your inclined plane. So for the next video, you're going to learn about wedges and your screw. So that's all for this video. So thank you for watching and have a nice day.